Okay, now that we've looked at our rules of exponents, we're going to go ahead and apply them, some of them anyway, into our polynomials. So in this section, we're going to introduce polynomials as well as adding and subtracting. So let's go ahead and jump in and find out what polynomials are. So a polynomial, this is a single term or the sum or difference of two or more terms with variables raised to whole number exponents. So what is not allowed? You are not allowed to have variables in the denominators or square roots. And you are not allowed to have negative or fractional exponents. These will be different types of things, but they are not polynomials. Polynomials are the nicest things that we work with beyond linear equations, and technically a linear equation is a polynomial. Now we do have some special polynomials. We have three. The first one is a monomial. A monomial is it is a polynomial, and it consists of only one term. So some examples: 4x squared is a monomial, 9 is a monomial, and negative 7a to the 19th b to the 5th. This is also a monomial. Remember that terms are separated by addition and subtraction, and since none of these have any addition and subtraction, they are all considered one term. All right, the second one that we have is a binomial. This is a polynomial that consists of two terms. So for instance, 2x plus 4 is a binomial. 3a to the 5th plus 6bc is a binomial. And negative 9x to the 7th minus 6 is a binomial. The last kind of polynomial that has a special name is called a trinomial. And a trinomial consists of three terms. So for instance, 3t cubed plus 4t plus 7 is a trinomial. And 4x squared minus 6x minus 1/2. Is 1/2 allowed? Yes, it is, because remember that we just said you are not allowed to have fractions as exponents. So you can have negative numbers in your coefficients or as constant terms, and you can, as long as they're just the number part, that's what we care about. If it has more than three terms, it is just a polynomial. It has no special name. So for instance, 4x cubed minus 5x squared plus xy minus 8 has four terms. We just call it a polynomial. Similarly, 4x to the 6th minus 3x to the 5th plus x to the 4th minus x cubed plus 2x plus 1. This has six terms. This is also just a polynomial. All right, a little bit more vocabulary. The next thing that we have is, once we've determined our polynomials, we want to look inside our polynomials. And so some things that we have something called degree of a term. This is the total number of variables being multiplied together inside a term. So if there's only one variable or one type of variable, the degree is just the exponent. X cubed, that's actually 3 x's being multiplied together. If there is a product of different variables, the degree is the sum of the exponents. Now we are going to have to do that for every single term that is inside our polynomial. The next thing we have is degree of a polynomial. This is the largest of the degrees of the terms. Now this is going to be the thing that's most important to us. Once we determine the degree of the polynomial, we're going to look at that term in order to determine the leading term. The leading term is the term of highest degree. So we'll see that when we get into our functions, the leading term is actually very important in determining what our graph looks like. We also have leading coefficient. This is the coefficient of the term of highest degree. That's also going to be something that we'll look at more at when we get into functions. For now, we want to focus on descending order. Descending order is a polynomial that starts with the largest exponent, and then we decrease going to the right. We like writing polynomials in descending order because it is easy to, one, identify the degree of the polynomial, the leading term, and the leading coefficient. All of this can be found in the first term. Now, if you have multiple variables running around, we may want to write in something like descending order of x or y or a particular variable. And that means that we are going to focus in on that variable and write it in descending order for that variable. Okay, so let's go ahead and look at some examples of this. We want to write in descending order, and we want to identify the degree of the polynomial, the leading term, and the leading coefficient. So if we look at example A, if we write this in descending order, what is my largest exponent? My largest exponent is the x cubed. So this is going to be my first term. So we get 2x cubed. And we decrease from there. My next largest exponent is my x squared. So we're going to get 2x cubed plus x squared. We get minus 7x. That's my next highest exponent. Do you know what the exponent is if there is no exponent? It is 1. And my last term is always going to be my constant term, the 12. 12 has a degree of 0. So if we look at our exponents, are they in descending order? We have 3, 2, 1, 0. Okay, so now what is the degree of this polynomial? Well, since we only have one variable in each term, then the degree of each term is just the exponent. So for instance, we have our first term is degree 3. This is degree 2. This is degree 1 because we have 1x. This is degree 0 because we have no x's. So our degree, those are the degrees of our terms. The degree of the polynomial, remember, is the largest. That is going to be 3. What is our leading term? Now that it's in descending order, it's the first term. And our leading coefficient is 2. Okay, let's go ahead and look at example B. Example B, we have several variables running around. And so I want to write in descending order of x. I didn't want to put that up at the top just because I didn't have enough room. So let's go ahead and write in descending order of x and see what we get. So what is our largest power of x here? If we look across, it's this last term. That's going to be my first term. So we get 5 x to the 6th y cubed. Okay, what is my next largest power of x? The next one that I see is 3x cubed. I'm going to kind of check these off as we go along. The next one I see is minus 5x squared. I see plus 7x y squared. And then I'm going to do my y to the fourth plus 2. Both of these don't have an x in it, and so it's kind of up in the air as far as which one would go first. But as I mentioned earlier, I always like having my constant term last. Okay, so now let's go ahead and determine the degree of the terms for each one of these. So since we do have multiple variables running around, we want to add our exponents per term. So for instance, the first term, I have 6 x's and 3 y's. This is a degree 9 term. We add our exponents. 3x cubed, this is going to be a degree 3. 5x squared, this is going to be a degree 2. What about 7xy squared? Well, this tells me I have 1x and 2 y's. This is going to be a total of 3. Y to the fourth is degree 4, and again my constant term has a degree of 0. Alright, so now what is the degree of the polynomial? It's the largest of my exponents for the terms, and so this is going to be degree 9. My leading term, well, with it being in descending order, I can just look at the first one. It is going to be 5x to the 6th y cubed. My leading coefficient is 5. Okay. All right, that's it for our vocabulary for polynomials. So now let's go ahead and get into simplifying and adding and subtracting. Let's do some stuff with this. So the first thing we want to talk about is simplifying polynomial expressions. In order to do this, we are going to identify and combine like terms. Like terms have same variables with same exponents. So that means everything but the coefficient must be exactly the same. We want to combine the coefficients and keep the same variables with the same exponents. We also want to write in descending order, just to make it a little bit easier to read. Okay, so if we go ahead and do this, let's see what we get. So we have example A. The first thing is what can we combine? I can combine 9x cubed minus 2x cubed, and we get 7x cubed. We're going to add our numbers or subtract our numbers. We keep the same variable, we keep the same exponent. All right, that takes care of my x cubes. Now you can move to 5x, but I actually, since I said I want this in descending order, I'm going to come over to my x squareds next. Negative 4x squared plus 5x squared. Negative 4 plus 5 is 1, or just x squared. And then I can bring down my 5x. This is considered simplified. All right, B. I want to know, are all of these terms the same? And the answer is no. Make sure everything, if it's an x squared y, it has to combine with another x squared y. X squared y and xy squared are not considered the same term. They are not like terms, so they cannot be combined. So let's see what we can do here. I can combine 3x squared y with negative 3x squared y. Those actually cancel. I can combine negative 5xy squared and negative xy squared. We get negative 5 minus 1 is negative 6. And I bring down my xy squareds. All right, so that is simplifying polynomials. The last thing we want to do is add and subtract. Okay, so this is basically just going to be one more step above simplifying polynomials. The main difference is that we're going to have these parentheses in here. And all the parentheses denote is this is one polynomial and this is another polynomial. So the first thing that we want to do is we want to clear the parentheses. And in terms of addition, the parentheses have no special meaning. They are just kind of a grouping symbol. But for subtraction problems, we want to make sure that we distribute the negative sign to all terms inside the parentheses. After that, we can combine like terms. So let's go ahead and look at some examples. If we look at example A, again, parentheses have no special meaning here, so if you want, you can ignore them, or you can rewrite the problem without them. So I'm going to bring down my negative 3x cubed plus 2x minus 4. And I'm going to bring down my 4x cubed plus 3x squared plus 2. We combine our like terms. I can combine my x cubes. Negative 3 plus 4 is 1, or just x cubed. I have my 3x squared. Again, writing in descending order. I have my 2x. And then I have my constant terms. Negative 4 plus 2 is negative 2. All right, let's try one more. Again, I want to write without parentheses, or again, if you want, you can just ignore them. We get minus x cubed plus 7x squared minus 2. So if we combine, I can combine my x cubes. I get 3x cubed, because we get 4 minus 1 is 3. I have my 7x squared. Doesn't have anything to combine with. I have my 4x, also doesn't have anything to combine with. And then I have my constant terms, negative 5 and negative 2, combined to give me negative 7. All right, so that is addition. So let's try some subtraction problems now. So this one we do want to be careful because the minus sign in the middle, we do need to do something with that. So the first set of parentheses, we can go ahead and just bring that down. Parentheses have no special meaning around the first set. But in the second set, we do need to distribute the negative. So we get minus 2x squared minus negative 5xy becomes plus 5xy. And we get minus 7y squared. All right, so now we can combine our like terms. I can combine my x squareds, negative 3 and negative 2 combined to give me negative 5 x squared. Four xy and 5xy combined to give me positive 9xy. And we bring down our minus 7y squared. Now this here is in descending order of x. Just to kind of show you why we do the of x. What is the degree of each one of these terms real fast? Well, this is a degree 2. This is also a degree 2. And this is a degree 2. So we do need some kind of organizational scheme. And that's why we say descending powers of x. If we go by descending powers of x, I've got 2x's, 1x, and 0x. All right, last one. Let's see what we can do with this one. So again, I'm going to get rid of my parentheses. So the first set, I can go ahead and just bring down what we have here. Second set, I want to distribute my negative, so I get minus 3x to the fourth plus, we get minus negative 9x cubed becomes plus 9x cubed. We get minus negative x squared becomes plus x squared. We get minus 7 is minus 7. All right, if we combine like terms now, we have our x to the fourth, cancel. My x cubes, I am left with negative 2 plus 9 is 7 x cubed. I have an x squared. It doesn't have anything to combine with. So I'm just going to bring down x squared. I have a 6x. Again, I don't have anything to combine it with, so we're just going to bring down 6x. And then I have my constant terms, negative 1 and negative 7, give me minus 8. And so we are done with that problem. It is in descending order, and it is simplified. All right, that takes care of our adding and subtracting polynomial expressions, as long as all of our terminology for this module. In the next section, we're going to look at adding and we're going to look at multiplying polynomials. All right, go ahead, take a quick break, and I will see you again shortly.